I hope you find this very, very interesting because we are really learning a lot about Earth's history, and it is amazing, really amazing that the continents can move and they can crash into each other, volcanoes can erupt, and magma can keep pouring out and has violent explosions or gentle intrusions and so on and so forth, and all that leaves nice evidences of the past and how the mountains got built up and the oceans changed and the seas formed and disappeared and so on and so forth. So you can obviously remember we talked a lot about ice. Here it's called ice, but usually it's glacier on land, of course, glacier. So Quaternary Ice Age deposits are found across most of the Britain and Ireland, which Ireland. If you remember Quaternary, maybe I should go all the way back and remind you. Wow, this is not separated here, but out of this Cenozoic, a sub-period is Quaternary. So we'll look at another scale, maybe that'll become clearer, right? So remember, glaciers flow like molasses, and wherever there is a slope it can flow in different directions, which is what it has done over the UK as well. These relatively thin surface deposits are not shown on the map as they would obscure the underlying rocks. In the diagrams above, the whites are the slow white area shows the maximum extent of glacier during the most recent glacial advance, which was till about 12,000 years ago, when it all melted back, right? And then the Holocene started. We became agriculturalists from hunter-gatherers and so on and so forth. This ended 10,000 years ago and the Holocene started. There have been many such advances during the past 2.6 million years. Each advance is followed by a warmer interglacial period, and we can think of this as a warm interglacial period when the glacier melts and retreats, which means coming from the polar regions into lower latitudes and then going back. Going back is what we call glacial retreat. We are now in an interglacial period, a temperate phase within a continuing ice age. Imagine that. We said orbital changes cause ice ages, right? They can start building, ice albedo feedbacks happen, and they can start melting, and ice albedo feedback happens. So these are natural cycles, and we should have been in the natural cycle of having ended the last ice age from the orbital changes and now building again, except we are now producing more and more greenhouse gases. And what are we doing to the natural ice age that may have started? Are we delaying it? So these are key questions. So let's look at some more past evidences of deserts. So evidence of desert dunes are present, and you will see it as sandstones with a crusty red color. Desiccation rocks, salt and gypsum deposits indicate an arid climate. Examples are seen in Cork and Kerry from the Devonian period and Cheshire from the Permian to Triassic. I'm using again period as a loose word, you have to be careful. So here is how the environment would look like when the desert was present and when it disappeared and became more wet. Then this is the kind of evidence you would find of the past deserts in that area. So the environment would be hot, arid to semi-arid with some rivers and temporary lakes, wind-shaped sand into dunes, rivers deposit sand and gravel along the channels. Evaporation forms salt pans. Remember, if the ocean water is coming or the river has a little bit of salt and it keeps evaporating, that salt is left behind and you have salt pans that are preserved in these paleo evidences or paleo proxies. Let's look at a couple of more. Cold and temperate seas and ocean depths. The environment looks like this. coastal waters to deep seas in cold to temperate latitudes. Sand and mud accumulate on the seabed in layers, and if you go to the Mediterranean, in fact, there is a mountain of salt from 6 million years ago. That's called the Messinian period. Okay, the evidence comes in sandstones and mudstones, again containing fossils of marine plants and animals. For example, central Wales and southern uplands from the Ordovician to Silurian, and other regions have from Neoproterozoic, means the late Proterozoic, which is very old. Remember, Proterozoic is the early life, 2.5 billion years ago to 542 million years ago. Ocean depths have the environment like this, with geothermal vents and all these reefs forming, so the environment would be deep, cold, dark ocean floor. Mud slowly settles to form a ooze on the sea rock, with black smokers and ocean bottom hot springs forming metal rich layers. They are coming out of the mantle of the earth and bringing lots of energy and chemicals and forming these smokers and so on. Evidence comes in thick sequences of fine material like sedimentary rocks, mainly mudstones containing fossils such as graphites and grapholites and trilobites, and examples come from Cambrian and Ordovician. So that reading with poor printing is done, and let's see if we can do better this time. So let's go back to 4.6 billion years ago, or 4600 million years ago. Remember that 1 billion is 1000 million when the earth formed. 4.6 billion years ago we had the Archean, the early the beginning, when we have rocks that are that old that preserve evidence. And the little town I come from called Dharwad in the state of Karnataka in India has some of the rocks from the Archean called the Dharwadian. Many geologists go there to study these unique things. And 2500 million years ago or 2.5 billion years ago, there is some gaps in the evidence, but they will be filled, I'm sure, in your lifetime, or maybe they will remain as gaps. So we started the Paleoproterozoic, the old visible life, and there are some symbols here which I'll ignore for now. And another time gap here, 1600 million years ago or 1.6 billion years ago, and we get into the evidence for Mesoproterozoic or Mesoproterozoic, where you have the middle early life. Okay, so that's 1 billion years ago. If we go further, so here you see the sea level and the temperatures, and they are reconstructed, so they are always anomalies from the baseline. You cannot get evidence for total temperatures or total sea levels from the past. You get deviations from the present temperatures and present sea levels. I won't pay too much attention, but you have to remember there were ice ages when temperatures were very cold. You don't see the red line here, but we have evidence of ice ages. And then the temperatures got warmer, and then you got another ice age starting, so temperatures started cooling. I have cut this scale into pieces, so we will see this going up and down. So I just want to point out that there have been ice ages and deglacial periods, or warm periods, ice ages again, and deglacial periods and warming again. And so you have to be careful because the scale is reversed here, so you have to be careful, because when the red is here, the ice age is happening, and so on and so forth. Paleo people do that. It depends on whether you are showing temperatures warmer going up or colder going up in past climate. or you have to think of it as coming from here. So you are coming from here because time is going this way, because you are going here from 542 million years ago to 488 million years ago to 444 million to 416. So you are going this way, so you are going this way as well. And you can see the redistribution of continents or reconstructed continents here. The northern half of Britain and Ireland occupy the position south of the equator here, that somewhere here. So this is the UK and Ireland somewhere here, and this is all the land. This is North America, this is northern Europe, and so on and so forth. So sorry, the figure quality is low, but you can just listen to my words, but these are clearer here. So now we begin to see some life in the Neo-Proterozoic. Proterozoic is early life, 542 million years ago, and before the Precambrian. So you have Charnia, the earliest complex life with multicellular life, and here you have paradoxites or trilobites with a bilateral symmetric around this line here during the Cambrian. And then you have all these graptolite and nautiloid and sea scorpion and so on. So you have plants evolving as well. We are only looking at the UK here, so you have to be careful. And then you have continents moving around, temperatures changing, sea level going up and down, periods changing with some mass extinctions happening. Is jawless fish and early land plants. Remember, photosynthesis took off. And then you had amphibian ancestor, the corals, the dragonflies, the tree ferns, and the cartilaginous fish. Cartilaginous is how many English speakers would say it. Early reptiles evolved, and you are now here into the dinosaur era. Another mass extinction happened here at the PT boundary, the Permian Triassic boundary, which starts here. So you have reptiles, flying lizards, and ammonite and marine reptiles, and various names are given to these formations, the Pangea, the Gondwana, and so on and so forth. And you have the dinosaurs here now, the Plesiosaur, it's a marine reptile. And then you had again more things, the dinosaurs, max extinction of 65 million years ago. Now the continents are looking more like what we have now. You can see clearly Africa, South America, North America separated by long distances, northern Europe here, and you have Siberia, and India is still here just close to the equator when you get to the dinosaurs, and so on and so forth. Okay, so here you get to the Quaternary in the last few million years ago, and you had fossil evidences for bigger and bigger things like the woolly mammoth. And you probably read about scientists wondering whether to recreate the woolly mammoth from the preserved DNA in ambers or ice, and so on and so forth. Okay, so that finishes the story from the report of the British Geological Survey, the Ireland and North Ireland Geological Surveys. We'll come back and go back to our Gail Herman's book, right? Book on what is climate change. So life will be simpler again. So these podcasts in the middle you can skip if you already know this, or if it doesn't interest you so much in terms of details. So you can make that choice, right? So that's good. See you in the next podcast, kids.